All right, so this is lesson 4, determining the angle measure from a trig ratio. Now, this is basically something we already did back in Math 10C. We'd have questions that were like, here's the ratio, what's the angle? Now, it gets a little bit trickier here because our calculator only gives us the reference angle. It doesn't give us the entire thing. Now, it's not that big a deal, and we already kind of did that last year in Math 20-1. We saw that we had to check in 2 places. So we'll go through that and make sure that it makes sense, and then we will start jumping into some other content with this idea in the next section. So here's an example, though. Cos of theta is negative 0.5. So what I do with my calculator is, let me just hold this calculator up here. What I would do with my calculator is go second quit, second cos to get my cos inverse button, which is really what we're doing. I put it as 0.5, and again, what I'm doing is getting just the reference angle, which is why I always use the positive ratio. I put myself in degrees just because it wants me in degrees for this one. So that's 60 degrees. So my reference angle is 60 degrees. For cos to be negative, I need to be in either quadrant 2 or 3. Those are my 2 negatives, so 2 or 3. So in quadrant 2, the rotation angle is 180 minus reference. And in quadrant 3, it's 180 plus reference. So this is 120, and that is 240. Now, if we've already done the unit circle, and I recommend we try and do the unit circle first before we do lesson 4. Unit circle is lesson 5. This is one of my unit circle values, and I'm just like, oh, yeah, my cos is 0.5 on my this family, and if I'm in quadrants 2 and 3, it's just going to be that line and that line. Those are my 2. Cos is 1/2. Remember, sine e cosec tandem. The cos is the x. There's my x equals 0.5 line, and there's my 120 and 240. Just no button pushing necessary. Here we have a slightly different one. Sine squared, so sine theta all squared, we will write as just sine squared of theta, just because we're lazy. This thing equals this. So when I see this, what I really say is, oh, that is sine of theta all squared equals 1/2. Now, first order of business is to take the square root of both sides. Square root of 1 is 1, square root of 2 is 2. And then that's my value.
Please call in, please, 1501, Mr. Grant, thank you.
Remember, it's also plus minus, so it's the positive root and the negative root, because when I take the square root, I need both. Now what I do is I'm going to sine inverse that, but I always use the positive 1. So it's just going to be sine inverse of 1 divided by square root 2. Close my bracket. That's 45. But because I want plus and minus, I actually need all 4 quadrants. So that one, that one, that one, and that one. And again, if we've done your unit circle, it makes it a lot more sense. But taking this off here, I'm just going to start digesting through. And so this is going to be 45, 135, 225, and 350. Again, it's 180 plus that value, 180 minus that value. That's kind of our process. And then 360 minus. Those are values. But that's the things that answer our question. Now again, I can always double check, right? I can prove that that is true, and confirm that that's the correct answer to myself just by running it back through. So I can go sine of 45 degrees squared. Oh, look, it's 1/2.
Mr. Grant, please call the main office. Mr. Grant, call the main office.
Sine of, clear that out. Sine of 135. Square it. Oh, look, that's 1/2 too. So I could confirm it for all of my values, just checking, which is really nice. Angle in degrees from reciprocal trigs. So if we see this thing, cotan of x, or cosecant, or secant, this is the part that's new this year, we just go, well, that's a dumb question. What I would really like to know is tan of theta, it's not a really good t, but tan of theta equals 1 over root 3. So I just reciprocate both sides. Now remember, this is the reciprocal and not the inverse. It's the exponent. So it goes 1 over this, 1 over this. 1 over cotan is tan, and so that's my process there. And then tan theta is 1 over root 3. This is again one of our exact value ones. So once we've done our unit circle, we just go, oh, there it is. But assuming we haven't done our unit circle, I'm going to go tan inverse of, again, 1 divided by square root 3, close bracket, close bracket. That gives me 30 degrees. And then I know that tan is positive, and tan is positive in this quadrant and that quadrant. So my answers, my solutions are going to be 30 and 210. Sometimes they won't be nice values. So if I've got this thing, first thing I do is go secant x. That's a dumb question. What I really want is cos of x, each one has a cos, is 1 over that value. And that's how we put that together. So now I'm going to go x equals cos inverse of 1 over negative 1.2631. Sorry, positive. We always use the positive value because, again, what we're always getting here is a reference angle. So inverse cos 1 divided by 1.2631. You will sometimes also hear the phrase arc cos used for this. The arc cosine is another term for the inverse cos graph. Anyway, x is going to be 37.6 or 38 rounded. But again, that's only in one quadrant. I have to think about where is cos positive, and it's here, but it's also here. So if I go 360 minus 38, I should get 312 if I do that right. Let's go. Let's just try that out, shall we? Just for fun. Yay, mental math. No, I didn't do it right. It's 322. Look at me go. It's a good thing I'm checking my own work. You probably knew that ahead of time. You're probably screaming at the screen, no, McManus, 322, not 312. Anyway, I couldn't hear you. My apologies. This one, again, I just rewrite as sine of x equals 1 over 2.45. X equals sine negative 1, 1 over 2.45. So, arc sine 1 divided by 2.45, and there we go, 24 degrees. And so sine, though, is positive in quadrants 1 and 2, so 24 degrees and 180 minus 24, 156. I'm mostly sure of that one, even though I can't write it apparently. Let's try 156, not 16. And again, just to be sure, check that out, 156. Look, and now watch this. I could take that number, I could do the sine of that number. Oh, that gets me to that number. And then I can flip it, 1 divided by my answer. Hey, look, we're back to 2.45. My solution works. All right. Sometimes we'll get something like this. Cos of x or cos of theta equals 0. I can do this. Cos negative 1 of 0 equals my theta. And if I type that in there, where's my calculator going? There we go. So arc cos of 0. Look, that's 90 degrees, which makes sense. So theta equals 90 degrees. Now, for something like this, I have to go, wait a sec, this doesn't make sense. Cosecant theta is undefined. what we want to think about is this. Cosecant theta is undefined. The way we get undefined is dividing by 0. So when we flip that into a sign, we get that. Now, as it turns out, if I do this, arc sine of 0, wait a sec, that doesn't make any sense, but actually it does. Because my horizontal line, where my y values are 0, or my sine is 0, are right here and right here. So again, I have two solutions, which are going to be 0 and 180 degrees. In radian mode, basically it's the same thing, except we're now dealing with pi's. So almost the exact same thing. Now, if, again, I've done my unit circle, I'm in great shape. I'll show you some cool tricks even if I haven't done it. But for this, I'm just going to go, okay, theta equals cos negative 1 of 1/2. That's that 60 degrees, right? So we're good there. Oh, but I wanted radians. Let's pop this back into radians. Second quit, second enter, enter. So it's 1.047 radians. Now, cos is negative here and here. So I'm just going to go pi minus and pi plus. So here's my favorite way to do this. I can just store this thing as A. There we go. That thing is now stored as A. And now I can go pi minus A. There's my one value, 2.09. Or I can go pi plus that A. Giving me 4. Again, if I wanted to, I could test that. If I do the cos of this number, it should give me negative 0.5. You ready? Moment of truth. Come on, math. Don't fail me now. Oh, look. It works. It's even negative. Love me. Now, here we have cotan. We go, oh, that's silly. We don't want cotan. Tan theta equals negative 4/5. Now, remember, the whole thing is negative, not like the top or the bottom. So it doesn't really matter where I put it. I could have had 4 over negative 5. That's going to be equally valid. And then, so what I'm going to do is just go tan inverse of 4/5. So that's that, 0.6747. And we want the one where it's going to be negative. The one where it's going to be negative is going to be in this quadrant. So it's going to be pi minus that number. So 2.466. We'll talk about this more later. The tangent is periodic over pi, so it only has one family of solutions instead of 2. If it's an exact value thing, and again, basically we're going to do all of this with our unit circle, but there is a way we can do this with our calculator. So sometimes you'll say exact value, and what we can do is we just take the reference angle that our calculator gives us, we divide out the pi. So we take the pi out, then we use our math frac button to get it as a fraction, and then we just write pi back into the numerator. So, for example, sine is 1/2. With my calculator, I can go, okay, arc sine 1/2. Make sure I'm in my radians. So there's my radian value, but I want exact, not this decimal stuff. So I first divide out my pi. Now I can take that number and math frac it. So that's really 1/6, and then I had a pi outside the bracket, so it's pi times 1/6, or pi over 6 is my solution. For this one, I go secant theta equals negative root 2. That's really silly. What I really care about is cosine theta equals negative 1/2. And now I just need to go theta equals cos negative 1 of 1/2 So second cos, that's that value there. Divide out my pi. Math frac. 1/3. So theta equals 1/3 times pi, or pi thirds. Again, cosecant is undefined. I say that's silly. What I really care about here is cosecant theta equals 1/0. Sine theta, which is the inverse tan of that. So sine theta is right. The reciprocal of that piece would then be just 0. And then I can go sine inverse of 0. That gives me 0. So theta is 0. Or technically pi. Hopefully that makes sense. Again, as always, if you have questions, come on in, and I'm happy to go through them with you.